and I work as an architect for a company called Adform, where we're doing online advertising, and in Europe actually, and we have development and operations here in Vilnius. We are doing Agile, or to be precise, Scrum, for 2 years now, and just 5 or 6 months ago, I gave a presentation during the Agile Day here in Vilnius, and I talked about Agile best practices, and awesomely, it was really total success, and you guys gave really great positive feedback on that. And then I tried just to understand why it was so great, and it seems that the main point was I was talking not about best practices per se, but about how our company tried to introduce those best practices, what challenges did we have, how we overcome those challenges, and so on. So basically, this was really the whole presentation about experience, about sharing experience from our company perspective. So I will try to do the same thing today, even though I'll be speaking about a little awkward thing. Who is here just because of the presentation title? One person. Yeah, so in the original version, it was F word there, F up, but I tried to make it more polite here, just, in case. Anyway, I'll be speaking about a thing called release often, but safely. And then you will understand why this title is here. As I've mentioned, I tried to make this presentation not the theoretical one, but based on our company experience, and all examples will be real examples from experience. I hope you guys will love this. But before going on, I'll start with the successful software workflow or life cycle, at least in my opinion. And everything starts with the first version of your software when you release it. From that point, you have no chance to develop in production. Production is meant for customers only, and well, your software starts there. After a while, when you get some customers, you are getting first challenges as well, like bug fixing, like new features, rolling out new features, maybe scaling. And if you are doing well with all three things, then after some time you see that you have much more customers and even more customers. And one morning you understand that, heck, your business is dependent on this software, and it basically cannot go down, because otherwise, if your software goes down, it can be really risky for your business. So here a dilemma comes, to be innovative or to be stable. By saying innovative, I mean you're releasing new features quite oftenly, let's say once per 2 weeks, once per month, but you are taking lots of risk of introducing new bugs, of possible service downtime and stuff like this. On the other hand, you can improve your stability, and it means higher uptime, possibly better perception from the customer perspective. But to achieve this, you need to trade off, and you need to trade off the release cadence. So instead of a couple of weeks, it will be 3 months, 6 months or so. So both things have their advantages, disadvantages, and we as a company had very same question some time ago. So to be innovative, but in our case, we wanted both of worlds. So we wanted to be innovative and agile while staying as much stable as possible. And just to give you a little glimpse what stability in our terms mean. As I've mentioned, we are doing online advertising here in Europe. And for a particular part of the system that is responsible for serving ads, we have 5 nines uptime requirement. If you are good at math, it's 5.5 minutes of possible downtime per year. That's why we have pretty much, not extremely, but rather complex infrastructure with 2 data centers, with some extensions to the cloud for some regions or for some features. And basically, we are getting more than 500 million of requests per day. So stability in our terms is really important. But advertising business is really tough, and we need to be innovative there. So let's learn some kung fu of releasing often, but safely. Those are three challenges we had in our company ourselves, and to be honest, we are still having some of them, so we're learning. And this presentation is not just a silver bullet, it's sharing our experience and our pains. And I think it's not only our pains. So the first thing is rather important to detect issues in production as soon as possible, and I think it's not unique for us, it's probably everywhere. The second challenge related to releasing often and releasing new features to production. So we wanted to make this really safely. We wanted to release and test feature in production without actually giving user real stuff to work on. So it was kind of, you know, we are releasing, we are testing ourselves, but we are reducing possible impact on customers, and customers really don't see any new feature. And the third one, well, you have quite a lot of servers. It's really a good idea to have rollouts in a kind of controlled, more or less controlled manner, because otherwise just 20 servers can go down, and it pains. So I'll start with the first one, detecting issues in production as soon as possible. And it's no-brainer, the first thing you should do is have monitoring system in place, whatever monitoring system you actually want. But from our experience, it was rather difficult to choose one, and it took almost a year for us. We have quite a lot of various monitoring points or sources. We have databases, performance counters, web services. We need to aggregate some performance counters from various servers and to have single value and so on. So it took quite a long for us. We tried several different products and came out with the one we're using now. And just to give an idea, if you are trying to choose a monitoring software, it's really a good idea first to enlist all the possible monitoring use cases for your concrete system. Because with this list in place, it will take you less time just to select and try monitoring system. But be aware, having monitoring system in place doesn't mean that you can actually monitor your software. You can monitor servers, you can monitor connectivity, you can monitor operating system, free space, and stuff like this. But if the real value is when you can monitor your own software, to do this, definitely I'm not talking about logging. Logging is a must-have thing, it should be enabled, you should use it, so I just keep it. But what you actually should do and should implement is performance counters, service level agreement counters, SLA counters, and stuff like this. Well, actually, we invested some time at that team and implemented lots of different counters. For example, for each functionality, it's like requests per second for specific functionality, response times, and stuff like this. And this gives really great insight because you can correlate things like, if usage of feature X increases by 10%, CPU usage increases by 20%. By having counters, you can correlate those things. But if you don't have any counters within monitoring system, you see only one thing. You see that, okay, we have CPU utilization plus 20%. Why? So in this place, it's really straightforward to implement them, but they're crucial. And don't forget, when you have your performance counters in place, just have create some kind of baseline that you can compare with. Otherwise, it will be difficult for you to say, are you going better or worse? But, well, even though monitoring is great, but it's, well, not the same as just tracking user experience, whether it's still good or not as good. For this, well, personally, I think that automated functional tests are great. Because, well, first of all, they're designed to simulate or to mimic end-user behavior. On the other hand, it takes some time to implement them. We are doing automated functional tests. Unfortunately, I can't say that we have enough, at least enough for me, of those tests. But it seems rather complicated when you have big system to do those automated tests. Well, we have an ongoing process, and I hope in 6 months we'll have something to share with, but, well, ongoing process right now. Nevertheless, by saying automated functional tests, I mean UI tests and business logic tests, because this is exactly the thing you are interested in, whether the user experience is the same. If user clicks A, B, C, it goes to D. And on the other hand, business logic is correct, still correct. Definitely, automated tests are available when you're running them continuously, not the one time. So basically, now, what we have with automated functional tests, we are running after each release, those that we have. But definitely we'll go to running them, let's say, day by day, every morning, every evening, or something like this. Because only running them continuously, you can detect actual problems as soon as possible. And, well, just a hint. If you have more than one server, definitely write some kind of automated test. Otherwise, it will be just a pain of manual testing on 10 or 20 servers. Interesting finding. Lots of people who are starting writing unit tests and try to convince their managers that, well, we'll use unit tests. It will because of them, our code quality will increase, and yada yada yada. Well, actually it does, but it's really difficult to sell this to managers. What we find interesting that unit tests are really crucial when your software evolves. For example, you need to implement 2 new features. How can you ensure that those 2 features don't ruin existing functionality? And for these things, really unit tests are great. You just can run them and see what's going on wrongly. Definitely you need to have quite a lot of them. By saying quite a lot of, well, at least for moderate size of project, at least 300, 400. And definitely code coverage should be something more than 60, 65, 70%. So, interesting finding, and interesting that this thing can be sold to managers easily than just real improved code quality. We talked about one challenge we had about monitoring our system. Now talk about testing new features in production. And we have different types of rolling out strategies. We have more than 3, but I'll talk about 3 here. And first of all, I'll start why it's important actually to have to test your features in production. We have pre-production environment, we have integration environment, but none of them is identical to the production. The hardware can be different, the network topology can be different, locations are different, and stuff like this. So basically, the best testing is testing in production. But you need to do this safely. So why? When you deploy your feature, it's really crucial to start monitoring it, whether the resource consumption is okay, it not utilize all CPU, and because of this, all your databases just crashes. That performance impact on existing functionality is moderate, that your feature is stable enough, you don't have any kind of memory leaks or lots of errors, and so on and so forth. What I'll try to do, as I've mentioned, we have various rollout strategies of new features to production, but I'll talk about 3 of them here. And just to make it more real, because this is all from our experience, I'll give 3 real use cases we had and just, the solution we used. The first one is we had to roll out a new feature that integrates into core data collection pipeline. Just to make a clear vision, we are serving ads, and definitely we are tracking if user clicks on this ad or just the ad shows up and stuff like this. So we are collecting all this information into a single pipeline. So lots of data goes there. And we wanted just to inject some new functionality over there, to take some data from there and to, process in kind of different way. So any kind injection into data collection pipeline is risky for us. So we wanted to do it really safely. For this use case, we use so-called dark release. I hope nothing relevant to releasing in the dark, but still interesting name. What dark release is basically you're releasing to one or couple servers. Your feature gets all the real load, but that feature is not still available for the customers. It's available for testing only, for your purposes only. So basically, three things. The first one, you release to one or couple servers, not to all, at least not from the first release to all servers. Then your feature gets real load, so you can track the consumption, the performance, and stuff like this, impact on other features. And this feature is not immediately available to all customers. Just keep in mind, dark releases work best for new functionality, not for existing one. And when you are doing dark releases, be prepared for the worst case scenario, so you definitely need to have rollback package in place. So if anything goes wrong, you just can in a minute roll back everything back to the initial state. Here is the real notes from our release plan. And as you can see, we did this release in 3 days. It's not the final release, it's dark release, but in 3 days. The first day, we actually released all the infrastructure, like additional tables, users, installed Windows service, configured connection to the Amazon cloud, and stuff like this, without actually injecting or changing something in the data collecting pipeline. The other day, we actually released our feature to one of our 6 servers. And this feature is meant to be used with a couple of languages, for now with 3. And we released on one server for one language only. So we tried really to minimize the impact and see what's going on there, whether the resource consumption is okay, do we have any implications, is it stable enough, and so on. The third day, we just decided, okay, it seems stable enough, we are good with this, so just release this feature to all servers for all 3 languages, but still don't make it available for the customers. So just to try out whether it's going on well. We didn't have any hard deadline there, so we could just monitor and see whether it's okay. And in case of emergency, we definitely had a rollback package. So that was dark release. Another thing, another use case. Well, we are using .NET for development, and .NET has great thing like SQL connection pooling. The only if is that if you connect to one server only. So if you have a cluster of SQL servers, as we do, well, connection pooling is not working. So several years ago, we implemented our own SQL connection pooling mechanism. It worked pretty well, but from that time, we have triple much databases, and our traffic is 4 times bigger, I believe. So we started seeing something going badly, well, in occasions, not every time, but in some occasions, in some situations. So actually, team created another pooling mechanism with, fixing all the issues we had, at least known issues. And basically, we need to release this new pooling mechanism. The idea here is basically, like whether to use old mechanism or new mechanism, true or false. So for this kind of scenarios, really great things like feature flags and switchers. So basically, feature flag is kind of logic. If feature X is enabled, then do something for this new feature. The second thing, switchers, is like if switcher X enabled, then use new logic, else use old one. So in our case, it was more of a switcher than a feature flag, because we had 2 choices, new, old one. But just to cut a long story short, feature flags and switchers are really great just because you can control this feature for each server. So like with a switcher, you can turn on 1 server, on 2 servers, on 3 servers, on 20 servers, one by one. And this makes testing really easy because you can try on 1 server, you can try on 20% of your servers, and then on all, if you will. The only thing, and I'll be talking about this later, is, well, definitely you need to implement this kind of logic yourself. And the hardest use case we had so far, it took probably only 4 months just of testing. Well, I'll repeat one more time. We are doing online advertising, so we're serving ads. But, well, ads are sometimes pretty much smart, so we are doing so-called targeting. And targeting is basically, if you like iPhones, probably you would like iPad. And this one is called product targeting. We can target by location. So if you're in Vilnius, probably you're interested in Agile Tour. So basically, various kinds of targetings. And just more than a year ago, we have all the targeting logic within our single serving, core serving subsystem. So it was responsible for both targeting and serving ads. Basically, with increased traffic, we saw a need just to split those things. So we did some work and implemented brand new intelligent targeting subsystem. It was so brand new, not just new because we used NoSQL. At that time, we had no experience with NoSQLs. Our first initial release had 8 servers already. And the problem was because NoSQL was new for us and we didn't have any real-life experience, we didn't know how much servers actually we need in production. So, we tried mixing things, trying things, and to do this safely, because, well, remember, serving is 5 nines of stability. We had really pretty much tough times. And for this, we used so-called valves. Basically, valve is extremely similar to switcher, but switcher has only 2 modes, on or off. Valves has like a gradient from 0, meaning that your feature doesn't get any load at all, or basically is disabled. And 100% means that all the traffic goes through your feature. And valves actually are extremely great if you want to gradually roll out new features, and not just by turning on or off, but saying, okay, let's try with 20% of real traffic. Let's try with 50% of real traffic, and so on. So basically, we used, in our case, for this use case, a combination of switchers and valves. Basically, we had a switcher for each functionality, for each targeting, basically saying use old one or new one. And we had valve just to say how much traffic our brand new targeting system gets. So we could say, okay, we'll try have full load on our new targeting subsystem, but actually we are not using it. So we were duplicating traffic between old subsystem and new one. And well, appears it was really, really great thing, even though it required some development, because once it helped a lot. Without it, our serving will be just stopped in next 10 minutes, because we saw a bug that if targeting subsystem goes down, our serving is going down as well, and well, it was a mess. Thankfully, we had valves and switchers. So far, I've described all 3 rollout types I wanted to. Those are dark releases, feature flags and switchers, and valves. Definitely, we had some caveats and problems, challenges, let's say, while implementing those things. So I would like just to share with you. First of all, make sure that when you implement switch or valve, you can change those values, switch on, off, change from 20% to 40% without actually affecting existing users. Well, if you're a web developer, if you try changing values in config file, application pull restarts, all users are disconnected, it's not a good idea. So you just need to keep in mind that by changing those switchers and valves, no one of connected users should be affected in anyhow and anyway. Then make sure that you have at least really simple interface, plain HTML, whatever you want, to display the current state of all switches and all valves on all servers you are monitoring. Because in our case, that time, it was more than a year ago, I think we had 30 web servers, and each of those had switcher for 14 flags and valve for 14 targeting rules, and a valve for 14 targeting rules as well. So it was really a mess. We had a huge grid, and it was difficult just to track on which server what targeting rule is enabled and how much, using valve. So just visualize all this information and do this from the start. And last, but well, appears not the least one, make sure switches and valves are accessible only for trusted persons. For example, within your team, for IT departments, for trusted company people, and so on. We didn't have anything wrong, just to point out. But, well, when someone from your company can potentially disable feature, in production it's not a good idea. Accidentally, for example. So just make sure you have secured access. That's all for for testing in production. And the last thing is related to controlling rollouts and doing rollouts in controlled manner. So here, if you're using switches and valves, actually the rollout is basically by default, out of the box, pretty much smooth or controlled, because you can do this server by server, feature by feature, and so on. But just to make clear, don't assume that we are using switches and valves for each functionality. We don't, because it takes lots of time, and it takes maintenance time, development time, just to do this right. Because, well, if we release or introduce new switcher, it's in our code base for at least 2 months, and team should deal with this code that sometimes becomes obsolete. So it's not going for free here. For majority of rollouts that are less important or less that has less possible impact on our business, we're using so-called partial rollouts. And actually, partial rollouts is basically doing a rollout to some subset of server with newer version, and then redirecting all the users to this new version, trying to understand whether it goes okay. If not, just redirecting back to the first version, initial version. And if everything is okay, just installing new version there. In our case, we're doing it a little bit at scale. So the initial unit in our case is data center. So we're mixing data centers, installing to one data center, redirecting traffic to another one, and stuff like this. It works, but well, in our case, it takes something at least 30 minutes just for traffic to be redirected. It involves various DNS tricks and so on. Just an idea, because we have this idea as well. If you're interested in this and you don't want to implement yourself all these valves and switches, research on so-called application level load balancers. And I believe we are doing research on this as well, because they could potentially save you from developing all this load distribution logic within your code. So basically, what I was talking today about, 4 main things. First of all, make sure you have monitoring system in place, because it's really, really important if your business depends on that software. And just by introducing a monitoring system, don't assume that your software can be monitored as well. Invest some time to introducing performance counters, SLA counters, and stuff like this. Also, personally, I'm really a true believer here that I see automated functional tests as a functional monitoring of your system. So, doing the same or simulating end user behavior, it's really great thing. But, well, nevertheless, it takes some time to do this properly. And what we did see is actually our QA specialists were not all aware of programming in C# and stuff like this. And for doing this, we had internal trainings for our QA specialists, just to bootstrap them with programming in C#, using Visual Studio and so on. So it takes some time internally within the company, but I really hope that in next half year we'll have real results there. Basically, as you've seen, switches and valves are really powerful concepts for testing in production. They can really save your butt, but well, it takes some time, extra time for development and maintenance, as I've mentioned. So just make sure you are doing the right choice. If safety is important, try valves and switches. Is not so important, well, don't invest time. And personally, I think that dark releases are really, really the most cost-effective way of releasing your software to production and testing it there, because you can do it only to one server instead of 10, for example. You can enable only single feature, in our case, as you see, only for one language instead of 3. And you can just try. The great thing about this is your install package or your software actually is the same as you would install on all the servers simultaneously. So basically, it doesn't take some extra effort from the coding perspective. Of course, it takes extra time from the releasing perspective. You've seen we did this in 3 days instead of 1, but well, the risk should be calculated. And finally, partial rollouts are really great things. Having 2 versions in place, having real backup that you can just switch back to the older version is a really great thing. As always, it takes, need to have some data centers, or your application should be aware of a load balancer, and your load balancer should be smart enough just to say, okay, those guys going to the new version and those guys going to the old one.